Okay, so I told you yesterday we were gonna talk about, these would actually be, these are still hold apart, and these would be problems. I think these are type 3. So, you know from your everyday life that like not everything you do are the directions that you take perpendicular to each other. So that brings us to this type of problem and how to deal with it. So we probably should write that down. Not all vectors are perpendicular to each other, even though everything we've done so far, like when we started this using the Pythagorean theorem, we had right triangles, we had the x and the y components, it worked well. But if you're traveling in a way that you're not doing 90-degree angles all the time, you have to have a way to work with that. And you have to have a simplified way to work with that until you get either in the right place in pre-calc or calc. It depends on where it comes in down here. And I'm not really sure which class it comes into. I'm thinking it'll come in next semester for you guys. But until then, we need to break the motion into what you know and into right triangles. So we're going to look at the motion one piece at a time. You're going to have one motion one direction, which would really be like one resultant vector. We're going to have a second, or maybe a third, or maybe a fourth, it depends on how big the problem is, a second motion with a second direction that's not at a 90-degree angle, but perhaps is at an acute angle. And you have to know how to deal with that. We can simplify it, and it's not that hard to do, but you just need to know how to deal with it. So I'm just going to give you an example of what the wording in one of these problems might look like, and then we're going to talk about it a little bit more. You might see something like this. Let's say I have a plane, and it travels at maybe, I don't know, 50 kilometers per hour at 35 degrees. And then the plane climbs to 55 degrees and continues 220, or continues at 220 kilometers per hour. And it might say something like, find the resultant displacement. Now, when you look at this, you should be able to see, like, it's clearly different than what we looked at yesterday. And it's clearly different than what we looked at first. The first time we looked at it when we had two vectors, we didn't have any directions, really. It was like up, down, east, west. They were at right angles. We're no longer at right angles. So I have two in this one, different sets of motion, and two different angles at which those are occurring. So that would be how you would pick out one of these problems, and how you would know how to go about solving it, by looking at that. So let's talk about how you find r, magnitude, and direction. The way that we're going to go about using this or doing this is we're going to use something called, and we've used it before, vector sums. We're going to solve those resultants for their parts. Once you solve for them, yes. So I'm just gonna give you a list of steps, and then we're gonna work one. So the first thing you're gonna do, and we're just gonna call this for R1, and you would do the same thing, but you would do it afterwards. After you've done R1, you do the same thing for R2, or R3, or R4, however many there are. You're gonna start by using the law of cosine, or our, yesterday we used cosine theta is equal to x over r. And we're going to find x. And we're going to call it x1. And again, whatever I do over here, I'm going to do with my second vector. I'm not going to write it twice. Then I'm going to use sine in sine theta equals y over r to find y1. And over here, I'm just going to find y2. And over here, I found x2. So I find my x and my y components. The third thing I'm going to do is I'm going to combine components. So I want to find x total, and I want to find y total. So I will do this. X total is equal to x1 plus x2, however many x's there are. Same thing with my y. And I'm going through these steps, that way if we go away from it for a little bit and then we come back, you've got a path to follow. Y1 plus y2, and so on and so forth. So I have an x total and a y total. The fourth thing I'm going to do is I'm going to plug into my Pythagorean theorem, r squared equals x squared plus y squared, and eventually solve for my r. So this is really like x total squared, y total squared. And this r will give me the actual displacement for the whole journey. Finally, the last thing I'm going to do is what we did yesterday. I'm going to use my tangent inverse function of y over x to find my degree reading. So that gives me a set of steps I can work through, or I can flip back to if I need them. So now, let's have you put, let's put this one. I'm going to give you one. Put this one in your notes. And just put it there and don't do anything, because there's something we need to talk about before we start. Once you have it written, just stop for a second. Okay, so when you look at this, it should be a dead giveaway that this is gonna be one of the long problems. Because I've got technically two resultant vectors, because I've got nothing to go with them, and two directions. So that should key you in right away what you're gonna use to find this. Can I move this now that I got it? So I'm gonna start by identifying my R1 and my theta 1 and my R2 and my theta 2. My R1 would be 25.5 kilometers, and my first angle was 35 degrees. My R2 was 41 kilometers, and 65 degrees north of east. Now I want you to go back into your problem, and I want you to read, the hiker is going from her base camp at 35 degrees south of east. So if here's east, I have to come down 35 degrees. What direction am I going? I'm going down, right? And we talked yesterday about how rather than adding the 180 or whatever, we can just make it a negative. So I want to remember to make this negative 35. Now, I can pick to start with R1 or R2. I like to start with R1. So, let's solve R1 for X1 and Y1. And I want you guys to do that. It's exactly what we did yesterday. Solve it and then stop, and we'll see if we agree on what you have. Let's watch our sig figs all the way through. We should be rounding to the ones place as we go. Okay, so do we have our values for those two things? Let's check them. Who's got X1? Only Kirsten has it? What you got, Annika? 21 kilometers, do we agree with her? And Y1 would be Kirsten? Negative what? Okay. So, this is my Y1, this is my X1. And I really would keep this in good order because sometimes you have to go back and find things. So now let's solve for X2 and Y2. Anybody have any questions about how we got those? Okay. So you guys solve for X2 and Y2. Do we have them? Caleb, what'd you get for X2? 17 kilometers. And Clark, what'd you get for Y2? 37 kilometers. Do we all agree with those? All right, so then let's find our X total and our Y total. Kilometers. 22 kilometers. You agree with that? Yep. Okay, so now what do I do next? Good. Let's plug them in. R squared equals X squared plus Y squared. R squared equals, I can't forget, 8 squared. And this, technically, this is our total. My total displacement. My total resultant displacement. So let's see what that is. What'd you get, Faith? Yeah, that's R squared. You're right. Now what's R? That is the most often forgotten step in the whole process. 44 kilometers, you guys agree with her? Okay, so now we have R, but we're not done. We need to find our degrees. So we're going to use our tangent inverse of the y total over x total, or opposite total over adjacent total, which was tangent inverse 22 kilometers over 38 kilometers, is that right? That's good. So, you guys agree with them? So then I would write this, R equals 44 kilometers, 30 degrees. So there's a series of steps. There's figuring out what kind of problem, or what path to follow. But like I told you at the beginning, these are not very hard. So what I want to do, I don't know how much time we have left. We should be able to get this done. So you should be, I think you'll be homework 3. I want you to do the last 4 problems, but we need to look at 2 things before you move. On problem number 3, I'm going to read it. There's something you need to put in because I left it out when I typed the problem up. During a rodeo, a clown runs 8 meters north, turns 35 degrees north of east, runs 3.5 meters. So if he's running 8 meters north, what is my degree reading for that? 90. Yeah, 90. Then he turns and he runs 35 for 3.5 meters. After waiting for the bull to come near, the clown turns due east. What's my reading there? 0. 0. Add in there that he runs 5.5 meters. I left that number out. So he runs 5.5 meters at 0 degrees. Yes, so you have 3. Now, the other thing I want to look at is this number 4, because it makes you think a little bit more. An airplane is flying parallel to the ground, undergoes 2 consecutive displacements. The first one is 75 kilometers, 30 degrees. Notice how it says, and you have to think about these, west of north. So if I'm 30 degrees west of north, here's north, that's 90 degrees, right? So I have to add on another 30 degrees, so ooh, that's 120 degrees. That's something you have to watch for. And then what does it do? What did I have it do? Second is 155 degrees, 60 degrees north of east. So that does put us in this quadrant. So we're okay, we can just use 60 degrees. Okay, let me read what I typed again. Ah, 60 degrees, I go here. Well, if I go 60 degrees, I'm still at 30, so it works either way. We're still at 30. If you go 60 degrees east of north, that's 30 degrees, right? Okay? Yeah? Okay. All right, let's see. I thought maybe I missed something. Okay, so let's go. Let's finish up. I would look for a test in here. I think I told you yesterday, but I couldn't remember if I said Tuesday or Wednesday. I think I'm leaning towards Wednesday. You think that's great? Yeah. Oh, good. So you have it Monday? It's okay. You can try. And you can get yourself caught up there and you feel comfortable. When you don't feel comfortable, ask for help. Oh, the only thing here is, if they're laying down, we have to use this one is below the horizontal. You did it right. You did. I need to look at one that yeah. Okay, hold on. So if he's running downfield, we think of that as, what direction are you thinking? Okay, 270. So if he turned right, you would think of him as turning this way. So how many degrees would he turn right? He turns right 25, so we use 295. Yes. Yeah. Think of it as if you're drawing it. Yeah. So I'm kind of letting you talk your way through them today. What I'm going to have you do at the end of the period is just leave them in the basket. Then I'm going to look at them over the weekend to see how you've done on your own, and we'll talk about anything we need to talk about on Monday.